We learned in the previous video 3.6, how to find derivative using the definition of the derivative. And the definition of the derivative is given by f prime of x equals limit of f of x plus h minus f of x all over h approaches 0. So this definition can be applied to find the derivative of a given function. For example, if f of x equals 2x plus 1, then applying this definition, as we learned in 3.6, can give us f prime of x equals to a constant value, or for some other functions we may get some linear function, quadratic function, or any kind of function depending on the original function. So, and we learned last time that this definition can be applied to find derivative, but there is some problem here. The problem is that it's time consuming. You need to do many steps, to use many or to do simplifications from algebra in order to find the derivative, and that's in most of the cases takes a long time to be done, and we need to find some easier and sometimes straightforward method to find derivative. So using that definition, we can derive some rules of differentiation, so that instead of referring to the definition every time we want to find the derivative of a given function, we can apply some rules of differentiation, and then we can find derivative easily and without the need for many computations in most of the cases. Okay, so in this section we'll learn some of those rules. Let's start with the first group covered in section 4.1. The first one, if you remember from the last video, the last example in the last video, in video 3.6, we discussed the derivative of the constant function, and using the definition, and we found that the derivative of constant function is 0. So for example, if f of x equals 5, then the derivative of this function is equal to 0. Also, if f of x equals pi or 2 pi, this is a number. Pi is a number, 2 pi is a number, so derivative of this is 0. So if we have a constant function, then the derivative is 0. This is the first rule. And if we have a function, x raised to some power, we can apply the power rule. This is called power rule. This is called power rule for differentiation. If we have f of x equals x raised to the power n is any real number, then the derivative can be obtained by bringing the power here in front of the number and subtracting 1 from the power. I should write n minus 1 as a power. So this is the derivative of x to the power n. Let's take some examples. This is called power rule. For example, if f of x equals x to the 5th, then the derivative of this is the power, we bring it down, and then we subtract 1 from the power, we get 4. Also, f of x equals x to 1/2, then the derivative of this function is 1/2 the power times x to the power 1/2 minus 1, and that is 1/2 x to the power negative 1/2. If we have a function f of x, actually for this one you can simplify more. We prefer to write terms with positive powers or non-negative powers. So we have 1/2. We can bring this down here. It becomes positive 1/2. But we know that the power 1/2 denotes the square root, so we can replace it with the square root. So we can write the derivative in this form, 1 over 2 square root x. Or if you want to leave it in this form, that's okay as well. Now, if we have x to the power negative 3/2, then the derivative of this is the power negative 3 halves times x to the power negative 3 halves minus 1, and then negative 3 halves x to the power. Now we need to simplify this, and we can compute negative 3 halves minus 1, negative 5 halves, and so on. So this is called the power rule. The third rule is the same as power rule but multiplied by some constant. So if we multiply by constant, that will not affect our result. We just multiply the derivative by that constant. For example, if f of x is 3x squared, then the derivative of this function is, we have a constant, the constant first, then the power, this is n, the power is 2x to the power minus 1, and that is 6x to the power 1, but we don't need to write 1 here, we just write it 6x. Also, if we have f of x equals 1/2 x to the power negative 3, then the derivative is 1/2 times, this is the constant, and then times the power negative 3. Now we apply the power rule, x to negative 3 minus 1, and that's negative 3 halves x to the power negative 4. Now we have the rule, we reach rule 4. Rule 4 says that the derivative, this is the derivative, as you can see here. The dash here means derivative. Derivative can be distributed on addition and subtraction. So we just distribute here, put it here and here. Take the derivative of the function f, derivative of the function g, and put plus or minus as indicated in the problem. So, for example, if we have the function f of x equals 3x squared plus 5. Now we want to find f prime of x. What is derivative of this? Using the rule number 3, we have a constant 3 times derivative of x squared is 2x to the power 2 minus 1, plus what is derivative of 5? It's 0, because we can just find derivative of the first expression plus derivative of the second expression according to rule 4. So this is 3 times 2 is 6x, 2 minus 1, 1, plus 0, and that's 6x. Let's take another example. G of x equals square root x minus x. Now how to find g prime of x? When we have square root x, it's better to write it using in the form of x to the raised to some power, in the exponent form. So this is x to the power 1/2, and then we apply the power rule here. 1/2 the power x to the power 1/2 minus 1, that's the derivative of the first expression, x to the power 1/2 or square root x, and then we differentiate x. What is derivative of x? Now x has power 1, so when we differentiate, we bring the power here, and then we subtract 1 from the power. So that's 1 times x to the power 0, but x to the power 0 is 1. 1 times 1 is 1. So derivative of x is 1. You need to remember this. Now we simplify. We have 1/2 x to negative 1/2 minus 1, or 1 over, now we have 2 in the denominator. We can bring this down and the power becomes positive, and then we replace x to the power or the power 1/2 by the square root. Okay, so we can apply this rule. If we have more than one term, we just differentiate each term separately and then add them together or subtract them. Okay, more examples. Let me give you some other examples. If we have 2 square root x minus 1 over square root x. Now how to solve this problem? It's better to write it without using the square root notation. To write it as a power. So before we differentiate, we can rewrite as f of x equals 2 times x to the power 1/2 minus 1 over x to the power 1/2. And we don't want to deal with some expression in the denominator. We can bring this up here, so we get f of x equals 2 times x to the power 1/2 minus x to the power negative 1/2, because when we bring this up here, the power becomes negative. We change the sign of the power. Now we can, our function is ready for differentiation. So f prime of x is, this is a constant, will not affect the derivative, but I mean we just find derivative of the function here and multiply by that constant. And then what is derivative of x to 1/2? It's 1/2 x to the power 1/2 minus 1 minus. What is derivative of x to negative 1/2? The power times x to the power minus 1. And then we can cancel 2 from the numerator and denominator. We get x to the power negative 1/2 minus minus is positive. 1/2 x to the power negative 1/2 minus 1 is negative 3/2. Negative 1/2 minus 1, we can get a common denominator, and then the common denominator is 2, and then negative 1 minus 2, and that's negative 3/2. This is how we obtain this power here. Okay, and there are many examples we can apply these rules. So these are just simple examples on how to use these 4 rules. Now let's take some applications. We want to find the equation of the tangent line. What is the equation of the tangent line? It's y minus y1 equals m times x minus x1, where m is the slope. But here, since the slope of the tangent line is the derivative, we don't need to write m, but we replace it with, for example, dy over dx at x equals x1. What does that mean? That means the derivative computed at x equals negative 1, for example, here. Okay, so this is the same as the slope at negative 1, 1. So this is just a notation, dy over dx evaluated at x equals x1, because we are given y. But if we are given f of x equals x cubed, we just write f prime of x evaluated at say x equals x1, and instead of writing it this way, we can write it here, just evaluated at x1. So we can use this notation here. So these are just different notations depending on what we have here. If we have y equals, if it's written as y equals something, then it's better to use this form, dy over dx. Some people prefer to use y prime, just y prime at x equals x1. This is x1 and this is y1. Okay, so this is just a notation. Now, since we have this, the function, or it's written in the form of equation y equals x cubed, we can find now the derivative. What is derivative y prime, or dy over dx? dy over dx means derivative of y with respect to x. So derivative of y with respect to x is, what is derivative of x cubed? It's 3x squared, using the power rule. We bring the power down and then subtract 1 from the power. Okay, so this is the derivative, but we want to find the derivative dy over dx at, this vertical line is read at x equals x1. What is x1? x1 is negative 1. So when we substitute negative 1 here, we get 3 times negative 1 squared, and that's 3 times 1, because negative 1 squared is negative 1 times negative 1, which is positive 1, so we get 3. So the slope is 3. Now the equation becomes y minus y1, y1 is 1, equals the slope 3 times x minus x1, x1 is negative 1. And then this is plus, we need to solve for y. Y minus 1 equals 3x plus 3. I just distributed 3 over this expression, and then we add 1 to both sides. We get y equals 3x plus 4, and that's it. This is the equation of the tangent line to the curve y equals x cubed at the point negative 1, 1. And now how to understand this? We understand this if we graph the function. X cubed looks like this. This is x cubed. This is y equals x cubed. And then at the point -1, 1, this is -1, say -1 and 1 here. This should be -1, -1. Sorry, there is some mistake here, because when you substitute -1, you should get -1. So I'm gonna change this to -1, -1. So I'm gonna modify my computations a little bit. So here y1 is -1. I just changed this. I'm gonna use different color, -1 here, and that will be +1, and that means here in this step we just subtract 1. We subtract 1 from both sides. We get y equals 3x plus 2, and that's the only change here. Okay, so -1 with -1 is a point here. This is -1, -1 on the curve of y equals x cubed. Now we want to find the equation of the tangent line at this point. The equation of the tangent line looks like this. This is the equation of the tangent line. Now at this point the slope is 3. So the equation of this line is y equals 3x plus 2. So we could find the equation of the tangent line to the curve y equals x cubed at the point -1, 1. So the equation of this brown line which is the tangent line to the curve at the point -1, 1, -1, is 3x plus 2. Now let's do another problem. The equation of motion of a particle is given by s of t. This is a function of t. We can call it f of t equals 2t cubed minus 5t squared plus 3t plus 5, where s is measured in centimeters and t in seconds. T is time. We want to find acceleration. What do we mean by acceleration? Acceleration is the derivative of the velocity. So we have acceleration. This is called acceleration. And we have what's called velocity. V of t is the velocity. Now what is the velocity? Velocity is the derivative of the position function, this function s of t. The acceleration is the second derivative of the position function. What do we mean by second derivative? As you can see, I put double dash here. That means the second derivative of s of t. And by the second derivative we mean to find the first derivative, and then the resulting function should be differentiated again. So we differentiate the s of t, and we get a new function called s prime, and then we differentiate s prime to get s double prime. Or we can just differentiate v of t, because v of t is s prime. Okay, so we want to find acceleration. In order to find acceleration, we need first to find the derivative of the function, I mean velocity. So s prime of t is, what is derivative of the first term? It's 6t squared. I mean, I applied the rule number 3. We have constant multiplied by t to the power n, or t to the power 3. We bring 3 down here, so we have 2 times 3t to 3 minus 1, and that's 6t squared. Okay, and then we differentiate the second term. We have negative 5t squared. How to differentiate this? This is a constant, so we just write it here. And what is derivative of t squared? We bring the power down and subtract 1 from the power, and we get 10. 5 times 2, 10 t. And then we differentiate the third term. The third term is 3t. What is derivative of 3t? Is the same as 3x. 3 is a constant. 3 is a constant, and derivative of t is the same as derivative of x, as we explained before. It's 1. We just write 3. And what about the constant term? Derivative of the constant term is 0. So this is the first derivative. This is the velocity of the particle. Now we want to find the acceleration, so that means we find the second derivative of the position function s, or the derivative of velocity. So derivative of velocity is the second derivative of the position, so we differentiate again. What is derivative of 6t squared? We bring 2 here and we multiply it by 6, we get 12, and we subtract 1 from the power 2, it becomes 1. So 12t minus 10 times derivative of t is 1, and 3 is constant, so derivative of constant is 0. So the velocity is given by the acceleration. This is the acceleration. A of t is given by 12t minus 10. Now the question asks also, this is the acceleration as a function of time t, and then what is acceleration after 2 seconds? We just plug t equals 2 here, so 12 times 2 minus 10 is 24 minus 10, which is equal to 14 meter or centimeter per second squared. That's the unit for acceleration, and the unit for velocity is just centimeter per second. Now let's continue in the rules, and that's section 4.3. I skipped 4.2, we'll talk about it later, but since 4.3 is closely related to 4.1, I'll continue on 4.3. So here we focus on the product rule and quotient rule. If we have two functions that are multiplied and we want to find the derivative, we apply this rule. The first times derivative of the second, plus the second times derivative of the first. Okay, so let's take an example. For example, if we have x squared times, this is f of x squared times 2x plus 1, and we want to find the derivative, we can apply the product rule. F prime of x is the first is x squared times derivative of the second, derivative of 2x plus 1. What is derivative of 2x? It's 2, because 2 is constant, x has derivative 1, and 1 is here is constant, derivative is 0, so derivative of 2x plus 1 is just 2, plus the second, so this is the first, this is derivative of the second, now plus the second. What is the second? The second is 2x plus 1 times derivative of the first. What is derivative of the first? The first function is x squared. What is derivative of x squared? It's 2x to the power 1, so just 2x. Good. And then we can simplify. We get 2x squared, x squared times 2, plus 2x times 2x plus 1. You may distribute 2x over this. You get 2x squared plus 4x squared plus 2x, and those give 6x squared plus 2x, and that's it. This is called the product rule. We have two functions multiplied by each other. Let's take another example. For example, if we have the function f of x equals square root x times 3x squared minus 2x plus 1. We want to find the derivative of the function f. So here we have two functions. We apply the product rule. F prime of x is the first is square root x, times the derivative of the second. Derivative of this expression is, what is derivative of 3x squared? 3 times 2 is 6x, and we subtract 1 from the power, we get x. And what is derivative of negative 2x? It's negative 2. What is derivative of x is 1, and what is derivative of 1 is 0. So this is the first times derivative of the second. plus the second is 3x squared minus 2x plus 1. This is the second, times derivative of the first. What is derivative of square root? Square root, we dealt with this in this video, at the beginning of this video. So we can write it as x to the power 1/2, and then we find the derivative of this. What is derivative of this? 1/2 the power times x raised to power minus 1. We subtract 1 from the power. So this is derivative of the second term. So we get square root x times 6x minus 2 plus 3x squared minus 2x plus 1 multiplied by 1/2 x to power negative 1/2. You can simplify more, you can bring this down here, but this is just for purposes of applying the rule. I'm gonna leave it in this form. Now the another rule is called the quotient rule. As you can see here, we have two functions, f of x and g of x, and we have derivative. We want to find the derivative. How to apply the derivative? The denominator times derivative of the numerator minus the numerator times derivative of the denominator, all divided by denominator squared. So let's apply it on some problems. For example, if the function f of x is, for example, 3x over x squared plus 1, we want to find the derivative of this function. The derivative says, the rule says, the denominator is x squared plus 1. We put this into parentheses, times derivative of the numerator. The numerator is 3x, derivative of 3x is just 3. Minus the numerator, 3x, times derivative of the denominator. What is derivative of x squared plus 1? It's 2x, just 2x. Because derivative of x squared is 2x, derivative of 1 is 0, so it's just 2x. All divided by the denominator squared. The denominator is x squared plus 1, and we square it. Then we simplify. 3 times x squared is 3x squared. 3 times 1 is 3. Now minus 2x times 3x minus 6x squared, all over x squared plus 1 all squared, and then 3x squared minus 6x squared, that is negative 3x squared, plus 3 all divided by x squared plus 1 all squared. And that's it. We can leave it in this form. Let's take another example. If f of x equals for x squared minus 1 over square root x plus 2x. Now when we see square root, we can write it as x to the power 1/2. Now let's apply the rule. F prime of x is the denominator is square root x plus 2x. We don't need now to differentiate the denominator. When we differentiate the denominator, we deal with x to the power 1/2 instead of square root x. So the denominator times derivative of the numerator. What is derivative of the numerator? It's 4 constant times, now we bring 2 down, it becomes 2 times 4, 8x, and negative 1 is constant, so derivative is 0. So derivative of 4x squared minus 1 is 4 times derivative of x squared is 2x to the power 2 minus 1, minus derivative of 1 is 0, and that is 2 times 4 is 8x. So we get it here. So denominator times derivative of numerator minus the numerator times derivative of the denominator. Now we deal with x to the power 1/2 instead of dealing with square root x. So what is derivative of the denominator? This is the denominator. Derivative of the first term is 1/2 x to the power negative 1/2 plus derivative of 2x is just 2, because 2 times x, derivative of x is 1, 1 times 2 is 2. So we can write it here, and write 1/2 x to negative 1/2 plus 2, all divided by the denominator squared. The denominator is square root x plus 2x all squared. And here we don't want to simplify. We can simplify if we decide, but we don't need. So let me show you how to simplify if you need it. So we have x, square root x is x to 1/2. Now we multiply 8x by x to 1/2, so that's 8x to 1/2, and we add 1 because the power of x is 1 here. So when we multiply them, we add the powers. The power here is 1/2, the power here is 1, and that's a constant. Okay, and then we multiply multiply 8x by 2x, and that's 16x squared. This is the first part. The second part here, we multiply 4 by 1/2, and that's 2, and then x squared by x to the power negative 1/2. So we find the sum of the powers, 2 minus 1/2, or 2 plus minus 1/2. Then we get a common denominator. So this is x with raised to power 4 minus 1, 3. So x to the power 3/2. And then we multiply 4x squared by 2, and that's negative 8x squared. Then we distribute the 1, negative 1. Negative 1 times 1/2, negative 1/2 x to negative 1/2, and we have negative here, it becomes positive. Now we have negative 1/2 times 2, negative 2, and we have negative here, that's plus 2, all divided by the denominator. And you need to remember that we don't need to expand the denominator. We always write it in that way, as a function raised to power 2. We don't need to expand it. Now here, if we need to simplify more, here we have 3/2. So we have 8x to the power 3/2, negative 2x to the power 3/2, that's 6x to the power 3/2, and we have 16x squared minus 8x squared, that's 8x squared, and we have 1/2 x to negative 1/2 plus 2, all divided by square root x plus 2x all squared, and that's it.